All right, we're going to talk about trig identities. Some of this is stuff you already know and have already used, but some of this stuff we just didn't quite get to. The book that we used doesn't really give us a lot of problems on this, although it does give us this very handy graphic thing that's very nice to use. But I think this is something that could be important both on the state dual credit test, but also for those of you who take the ACT again. Some of this it can be pretty helpful on ACT problems as well. So I want to make sure we talk about it. And whatever math you go into next, whether that's a calculus class or like a college algebra class or something like that, I think that this stuff will be really helpful. So the reciprocal identities up here, we've already gone over all that stuff. You know that cosecant is the reciprocal of sine and secant is the reciprocal of cosine. We know that tangent is sine over cosine, and cotangent is the reciprocal of tangent, so that's going to be cosine over sine. So we've gone over that stuff. What's new here is what are called the Pythagorean identities, and the main one I really want to focus on is this first one. Sine squared plus cosine squared equals 1. I think that's the most useful one and the one that seems to come up the most. And if you know that one, a lot of the other stuff you can figure out without having memorized the other two. So here's why this works, why we know or how we know sine squared plus cosine squared equals 1. So I have this very basic looking unit circle here, and I'm going to make an angle right here. I'm going to call this angle theta. I have no idea the measure of this angle, but I do know that when it hits the circle at this point, that the x value will be cosine theta, and the y value will be sine of theta, because this is a unit circle, and that's how it works. We also know, because it's a unit circle, that this length right here is 1. Every radius on a unit circle is 1. So what I want to do is make a little right triangle out of this. So I'm just going to draw a perpendicular line straight down to the x-axis, and then draw this right here. So we got this little right triangle. We know the height of the right triangle is going from 0 up to this point. So that length on the right side of the triangle has to be sine of theta, because that's our y value at this point up here. I also know that the length on the bottom here has to be cosine of theta, because that's how far it is from 0 out to this point. And then if I do Pythagorean theorem, a squared plus b squared equals c squared, what I get is cosine squared of my angle plus sine squared of my angle equals 1 squared. And of course, 1 squared is just 1. And they wrote this in a different order than I did, but we know because of commutative property, when you're adding things, the order really doesn't matter. So you can simplify it that way. So that's why that works, and that one's really useful. The other two, I don't really want to talk about too much, because as a part of this assignment, you may end up having to demonstrate why one or both of these work. So I'll leave those kind of open-ended right now, and we'll get into the examples so you can kind of see where this is going. So here it says prove the identity, and this is obviously not one of the identities on our little graphic here. But it wants us to prove it, and to prove it, it means simplify this until we can demonstrate that this equation is accurate. So right now I see a lot of stuff on the right side, or on the left side. I see 1 over secant of x on the right side. By looking at this, I have no idea if this is accurate or not, but I can use information I know to simplify this and see if I can actually prove this. So what I'm going to do is I'm going to take everything I have here and write it in terms of sine and cosine. So secant, we know secant's the reciprocal of cosine. So I'm going to take secant of x and turn it into 1 over cosine of x. Tangent, I know tangent is sine over cosine. So I'm going to write it that way, sine of x over cosine of x. Then I still have this sine of x here. That's already sine. I'm just going to leave it there. On the other side, I have 1 over secant. So again, secant is the reciprocal of cosine. So I'll just write this off to the side. 1 over secant is going to be equal to the cosine, because they're reciprocals of each other. So this is going to be equal to cosine of x. All right. What I see I can do here with the second term, I'm going to just rewrite this first term. The second term, I'm going to multiply my sine of x right here by the sine of x on that fraction, since these things are being multiplied together. That's going to get me sine squared of x over cosine of x. And that will be equal to cosine of x. And there's different ways you could do this. You could find a common denominator. You already have a common denominator with these fractions, so you could put those together. So let's go ahead and do that. 1 minus sine squared of x over cosine of x equals cosine of x. So now what I usually like to do when I have a fraction like this is get rid of the denominator by multiplying it by both sides. So I'm going to multiply cosine of x here and cosine of x here. And what's going to happen is these are going to cancel out, and I'm going to have 1 minus sine squared of x equals, and I have cosine times cosine, that's going to be cosine squared. And now what I can do is I can look at my Pythagorean identities, and I see this right here. I know sine squared plus cosine squared equals 1. And so what I can do is if I just make this one little move and add sine squared of x to both sides, what I get is 1 is equal to sine squared of x plus cosine squared of x, which is something we have already demonstrated is true. So when we can get it to here, we know 100% that this is a true identity, that this equation actually works out. So that's what you're trying to do, is you're trying to work these things down until you can match them with one of these identities we already know, or until you can get to the exact same thing on both sides of the equation. All right, let's keep going. And what you'll find on these is there's not like one way to do any of these. It's a lot of trial and error and just kind of playing around with things until you can make them work. Here we have cosine squared minus sine squared of x equals 1 minus 2 sine squared of x. So right now, there's nothing that we need to rewrite in terms of sine or cosine. Everything is already in terms of sine or cosine. And right now, this doesn't really help us, because in our Pythagorean identity, the sine squared and cosine squared are being added together, not subtracted. So we've got to look for something else to do. Well, one thing I see is I see I've got sines on both sides here. So what I'm going to do is I'm going to move those together. So I'm going to take my this minus 2 sine squared of x. I'm going to add that to both sides. Again, sometimes you just have to play with stuff, and this might not have been the first thing you saw to do, but if you did something else, it's still going to be okay. You just kind of keep working stuff around until you get something that looks like something you can do something with. But anyways, I'm going to add my 2 sine squared of x over here. That cancels those out. And so now I have cosine squared of x. That doesn't change. But when I add 2 sine squared of x to this minus sine squared of x, it would be like a minus 1 sine squared of x. That's just going to be sine squared of x. And it's going to be positive. So this is like adding a 2 to a negative 1. So it's going to give me a positive 1. And then that is equal to 1. Well, here I end up at the same place I ended up on the last one. I didn't have to do too much to get there. I end up with this Pythagorean identity that sine squared plus cosine squared equals 1. So that one works out pretty nicely. And again, you might not have seen that as the first move, but even if you didn't do that first, say you moved this sign over to this side of the equation first, you could still eventually get there. It might have just taken another step or two to do it. All right, let's look at this one. And this will be the last one we do. This one's a little more involved here. We got cosecant squared of x times tangent squared of x minus 1 equals tangent squared of x. All right, so again, I want to rewrite all this in terms of sine and cosine. So cosecant, that is the reciprocal of sine. So I'm going to write this as 1 over sine squared of x. So one thing I probably have not mentioned as we've been doing this is even when you square these, they're going to behave the same way. So just like cosecant is the reciprocal of sine, cosecant squared would be the reciprocal of sine squared. It's still going to work out the same way. We have tangent squared here. We know tangent is sine over cosine, so tangent squared would be sine squared over cosine squared. So that's what that first term ends up looking like. It's those two fractions multiplied together. We have a minus 1 equals tangent squared of x again. So I'm going to write that as sine squared of x over cosine squared of x. All right, so I want to simplify a little bit. So right away I see in these two fractions here, we got sine squared of x on the top and the bottom, so those are going to cancel out. And this is going to become 1 over cosine squared of x minus 1 equals sine squared of x over cosine squared of x. Now, there's different ways we could do this. Let's do it two different ways. First way I'm going to do it is with the common denominator. I'm going to take that negative 1, and I'm going to make that 1 cosine squared of x over cosine squared of x. Because I know anything over itself is 1. So I'm going to try that. That is equal to sine squared of x over cosine squared of x. Going to combine my fractions now. So I have 1 minus cosine squared of x over cosine squared of x equals sine squared of x over cosine squared of x. Now what I can do is just multiply. I can cancel out this cosine squared of x by multiplying it by both sides. And I have 1 minus cosine squared of x equals sine squared of x. And this is starting to look familiar. All I need to do now is move this cosine squared to the other side. And I get sine squared of x plus cosine squared of x equals 1. That's my Pythagorean identity. So I have proven that this is correct. So that's one way I could have done it. The other way I could do it is just let's just multiply by cosine squared of x right away. Let's multiply the entire equation by cosine squared of x to cancel out our fractions, because everything's more fun if you don't have to worry about fractions. So when you do that, you multiply it by each term. You multiply it by the first term. The cosine squared of x is going to cancel out. You're going to get 1. Cosine squared of x times 1 is going to be cosine squared of x. And then on the other side, your cosines will cancel out, and you'll just have sine squared of x, which is actually where we ended up doing it the other way. We actually got there a little quicker. So I'm going to go ahead and do the same thing I did before. Add this cosine squared of x, and I'm going to get 1 is equal to sine squared of x plus cosine squared of x. So again, I get that Pythagorean identity, which verifies that this is correct. I will say on some of the problems on the assignment, you might, on all our examples, we ended up at this Pythagorean identity. On some of the problems on the assignment, you might not. And there's probably even ways we could have done this where we didn't end up there. You might just end up with like 1 equals 1 or sine of x equals sine of x. That also verifies it. If you can work it down where you have the same thing clearly on both sides of the equation, you verify that equation is accurate. But this will also come up a lot where it ends up giving you this sine squared of x or sine squared of theta plus cosine squared x or theta equals 1. And if you can get it to there, then we know 100% that is always true. So that's a way you can verify the equations as well. So good luck on this. I'm not giving you too many problems to do, and we can go over them in class on Wednesday too if you need a little help on it. But that is trig identities.